So there's a lot of different people out there that make what they call X-ray correct caps, but the problem you're going to run into is that people don't know what actually X-ray correct is. So there's a lot of different types of blasting caps or detonators out there, and the best place to look to figure out what the different types are not on the manufacturer's websites, because that's not going to tell you how they're internally constructed or built. Where you're going to find that information at is on the patent applications that these manufacturers will submit to a patent office. So if you go to like Google and search for patent for detonators or patents for blasting caps, that's where you're going to get the information that's going to tell you how these things are actually internally built. Now, the other problem you're going to run into is between a cabinet X-ray system operator and a bomb technician who's using a portable X-ray system. The big difference between the two of those is bomb techs work in a black and white world. They don't use color typically, and even the systems that do have color, they don't work very well. They're not accurate as far as materials discrimination is concerned. When you get into the cabinet X-ray systems, those are extremely accurate in regards to what we call materials discrimination, which they can tell you if something is a metal by turning the color blue. So for bomb techs, the darker the item is, the more dense it is. So typically they might X-ray something depending on the number of pulses. And if they see something very dark black, they're going to assume that that's going to be a metal. Now, when it comes to detonators, the mistake they always make is if they see something black inside of the detonator, they're going to automatically think that it's the lead azide, lead stephanate inside of the detonator. And that's where you're wrong. So with a cabinet X-ray system, you can tell the difference between something that's lead azide, lead stephanate, and something that's what we call a steel sleeve. Steel sleeves are extremely common today in blasting caps, and that's one of the things when you start looking at X-ray correct and the different vendors out there are absolutely missing. And I'll even have bomb techs or aviation professionals come to me and say, when we send them one of these caps that have the steel sleeve inside of them, they go, oh, that's not correct. No, you're wrong. It is correct. And that's what they're actually going to. So you need to get familiar with these type of blasting caps and detonators because they're becoming much and much more common. Now, the way they can work in a multitude of different ways. One, they can be used as a delay element. A lot of times the delay element inside caps will be made out of a plastic, but they can also use that steel sleeve as the delay element and combine it with a lot less lead azide, where it's actually almost packed in there in a small amount that it can actually set off the primary explosive much better than the big bulk that they were using in the past. So the other thing you got to think about is that all the ranges today, especially with me, I got out of the Marine Corps, I think in like 2000, but we had the EPA all over our Rangers with test instruments and all kinds of stuff, test spots that they could measure. And lead is a hazardous material. So the manufacturers are getting smart and taking the lead or lessening the amount of lead azide, lead stephanate that's in these detonators and blasting caps to also, one, make them safer, because that's the most hazardous explosive material inside of the blasting caps. So these steel sleeves are what they're using. Now, on a cabinet X-ray machine, this is going to show up in a blue color. On a portable X-ray machine, because bomb techs only use black and white, it's going to show up in a black color. And they're going to assume or think that is a lead azide, lead stephanate. It's wrong. Now, typically, the amount of lead azide, lead stephanate inside of a cap, number 8 strength, what have you, whether it's a instantaneous cap, it's a delay cap, fuse head, bridge wire, doesn't matter. It's only going to be about a 1/4 inch in size, and in some cases much less than that. When you start getting into the steel sleeves, you may or may not even see any black inside those caps. You'll just see that blue steel sleeve. And you have to get knowledgeable about these because they're becoming more and more prevalent out there with the commercial industry and the mining and the blasting industry. So if you see a cap and it doesn't have black in it and it's got blue, that's not wrong. That's actually correct, and that's where these manufacturers are going. So we're going to give you some different examples of what to look for when you're going to get into what we call X-ray correct caps, especially from a checkpoint X-ray side where they're teaching people on what to look for, and also from a bomb technician side where they're going to actually get into more things like diagnostics and things of that nature. And it also has to be X-ray correct. So the first one we'll show you is this one. This is an instantaneous bridge wire type cap, about number 8 strength. And again, this is going to have a lead azide, lead stephanate component inside there. And typically all of this is going to be at the back end of the cap. So if you're seeing lead azide, lead stephanoate, or a dark black material way down on the lower half of the cap, that's wrong, okay? Most of these caps, all of the business end of it, where all the explosives are going to be, are right here in this area. So if you see an extended length or amount of it, or a giant amount of lead azide, that's not correct. That's not X-ray correct. That's not how they make them. And a lot of this stuff that's out there right now just looks like absolute shit if you compared it to an actual real blasting cap, and how the engineering drawings or the diagrams show you where it's distributed inside the space of that cap. And almost always is going to be in the upper half of the blasting cap, okay? Now this one is going to be used for a bomb technician purpose. That's going to be used here in the U.S. for public safety bomb technicians. So this needs to be able to also show what we call continuity, okay? So that means that real caps, they do a continuity check on them to make sure the cap doesn't have any breaks in the wires and the circuit's actually good. And what they'll use is something like this. This is a little wizard device, like Bismos, other things like this. And before a guy ever sets up his shot, he's going to test his cap, and then he's going to test his wire. He's going to make sure all of his stuff has continuity, because if he goes to set the shot off and there's a break in the wire or there's no continuity, the shot's not going to go off, and then he's going to OBEER. That's how it works in the bomb tech community. So what this thing does is just a simple, quick test. It actually puts a very small amount of voltage through the cap, and this is regulated in regards to how much voltage in a bridge wire it takes to set it off. And almost all blasting caps, or even E-matches and squibs, are going to run about 1 to 1.5 amperes just for a single cap to actually push it. So this is coming nowhere close, so it's not going to set the cap off. But again, they use this to check to make sure the cap's got continuity. All right, so when I touch these wires to it, you'll notice that it lights up. That means that this cap has continuity. It's a good cap. So this is a kind of cap that would be more specialized. It could be used by aviation, but it'd be more specialized for bomb technicians, especially if they were doing, demo operations where they're going through the whole process of setting up the shot and then making sure that the cap has continuity. And this would also help them for what we call det diagnostics. This one can be used for that, so they can actually verify whether there's voltage in here or not. And it's a perfect cap for that scenario. So there's different varying levels of what you would call X-ray correct or a correct cap. It has to be technically correct, where the components on the inside of it are actually configured in the same way they would be in a real cap. And most of the X-ray correct caps that are out there right now are not doing that. You'll see a lot of people that are using what we call squibs. And these squibs or E-matches, this is them right there, they're used for fireworks, okay? You'll see a lot of guys try to use these to duplicate or simulate a fuse head. They are not even remotely the same. So if somebody's using this to try to simulate a fuse head type blasting cap, it is absolutely and completely wrong, okay? This is nothing like what a real fuse head looks like in a commercial or military style blasting cap. So a lot of people are using these to simulate commercial or military caps as a fuse head. That is not technically correct. It is absolutely and completely thoroughly wrong. Now, terrorists will use these in improvised caps. That's a whole nother different scenario. But again, this lower portion of this is actually a lead solder. That's not lead azide, lead solder. It's actually lead solder. It's part of the construction of this material. And the upper portion of this is going to be a pyrogen or a pyrotex type mixture. And depending on whether it's a fuse head, much stronger amount of an explosive material and different than in a commercial actually E-match or fireworks match. So this will show up in a black and white X-ray. It won't be nearly as dark as the lead, but it'll be slightly dark, and that's where you hear people say snake eyes. There ain't no fucking snake eyes, guys. But that's because the people that made that cap are making it with fuse heads or at these E-matches, and that's not how they look, okay? They do not look like that. So when somebody shows you a what they call snake eyes, what they're actually talking about is that the pyrogen mixture by itself in a real fuse head is going to show up in a dark color because they use some materials inside of it that are basically metals that's going to give it that dark color. And then right after that would be the lead azide, lead stephanate. So if you're seeing multiple dark spaces inside of a cap, especially down at the lower end, that's just wrong. Okay, it's not technically correct. And you can tell a lot of times if they're using these just by the wires that are sticking out of them and things of that nature. That's not a technically correct fuse head cap, and it looks nothing like that in the X-ray machine, whether you've got a checkpoint X-ray or whether you have a portable X-ray. And now there's a lot of confusion out there as far as what is an X-ray correct cap. Some people only know, an instantaneous cap with the bridge wire and the black stuff, and then, the explosive PET and RDX is going to turn orange. And anything outside of that, they don't know, and they think it's wrong. There are a lot of different style blasting caps out there. There's not just one guy. There's probably 10 or 12 different versions, and the steel sleeve is one that nobody seems to understand that's out there. So again, go into your internet, if the information's there, and Google or Chrome or whatever you want to use, patents for detonators. And you'll see diagrams that'll tell you that that's a steel sleeve. And bomb guys, just because it turns black doesn't mean it's a lead-acid stephanate. It could be that steel sleeve, okay? I'm telling you because I know this. I've x-rayed real caps, different types of detonators. I know what the fuck they look like in a cabinet x-ray system and the portable x-ray systems. So to try to dispel some of this confusion, especially with the products that are getting out there and these supposedly x-ray correct caps, go to the internet, go to the patents, look at those, and use that as a comparison. You'll see in there somebody's got an instantaneous bridge wire blasting cap. They'll list all the materials inside there. You'll see how they're spaced inside there, and you can use that to evaluate the quality of these different products that are claiming to be x-ray correct. Now, here we try to make absolutely sure that we have a technical document that supports what we're trying to do. Now, a lot of cases, it's extremely hard to simulate this. So to try to simulate a fuse head is almost next to impossible. You have to make it yourself. I figured out how to do it. But you can't use this because this is not what a fuse head looks like in a detonator or blasting cap. All right, so there's also copper caps out there. So in the oil industry and the drilling industry, they all use copper. And the reason they use copper is because it's a stronger metal and it holds up under the pressures, especially when it's down inside these wells and they're blasting with them. So copper is going to be an explosive type of detonator that's out there, and they're really common. They're a lot more common than people think. The problem is if you're a bomb tech or if you're an EOD technician in the military, you're only seeing one style of blasting cap. That's not all there is, guys. There's a whole shitload more of stuff out there that you probably don't know about. And the thing that I'm seeing is when guys get introduced to something they've never seen before, and especially if they're trying to work with something like an X-ray correct, they go, oh, that ain't X-ray correct. No, it is probably. You just got to do your homework and know what you're talking about. So copper style can have the same type internals in regards to the aluminum ones. You can have fuse heads, you can have bridge wire, you can have delay, you can have the steel sleeve, you can have the lead azide. They come exactly the same. The difference is the shell is going to be a copper. So with a cabinet x-ray system, these look completely different than your aluminum ones, which are going to show up different. You still would be able to see the lead azide, lead stephanate, but this whole cap's going to turn blue in your x-ray machine. And I have people, sending these caps, it turns blue, it's wrong. No, it's not wrong. You just don't know what the different types of caps are. And what's the most important thing is, especially for airport screeners or people running an x-ray machine at a security checkpoint, is you have to be training them on all these different types of caps that are out there. And if you only know one type and that's all you're showing them, if they get exposed to a cap, like let's say this, or one with a steel sleeve that doesn't have the black dots in it, they're not going to be able to register that because you never train them on it. So the reason I'm making this is that the community, the experts, the trainers, the guys that are out there, you need to get a lot smarter on what types of detonators and blasting caps are out there, okay? And you have to understand how the different x-ray machines work and how they're going to show it to you because it's completely different for a bomb tech on what they're going to see versus a checkpoint x-ray guy who's going to see this in a materials discrimination image. Your portable x-rays cannot do material discrimination. Trust me, I've tested them, they all fail. So I hope this helps. I hope it gives you some information. Go to the pubs, go to the websites, go to the patent office. They've got the diagrams there. You can learn a lot about detonators and blasting caps from there. And again, bomb guys, don't mistake a steel sleeve for lead azide, lead stephanate. Also, the steel sleeve is typically twice the size of what you would see with the lead azide, lead stephanate. It could be almost like a ½ an inch in length. Okay. I'll try to post some images of the different real types of detonators and blasting caps that are out there when I post this on LinkedIn. But if you have any questions, reach out to me. We'll be glad to help you. And I hope this helps. Have a good one.